Hi, this is Ahmad Mirabi. Let's solve a question. Okay, okay. Let's solve this sample question. The question says for the quadratic function y equals 2 times x plus 3 squared plus 4. Find the coordinate of the vertex. And then in part B it says does the graph open upward or downward? And part C says find the equation of axis of symmetry. And part D says find the domain and range of the function. Before starting to solve this one, let me give an explanation of how the translation of function work, and then going through solving the question. Okay, if we have a parabola, if we have a base case which is y equals x squared, which is a quadratic function, and if we want to translate it 1 unit to the right, the equation will be like this, and the graph will be like this. So translating 1 unit to the right is like this, and translating upward or downward will be like this. For example, if it is x squared minus 2, the graph will be translated 2 units down, so like this. And if we combine these two, for example, if I write x minus 1 squared minus 2, the vertex goes 1 unit to the right and 2 units down. And here I draw the parabola upward, and it opened upward because the coefficient of x squared is positive. The coefficient of x squared is the same as a here, and if a is positive, the concavity is positive, or the parabola opens upward, and if a is negative, the parabola opens downward. Okay, the other point we need to mention is that this coefficient is not always 1. For example, if we have y equals 2x squared, the only difference it has with the main y equals x squared is, let me change the color of my pen and here draw it. We can say that the graph will be more sharp, or it will be in y direction. It will be extended. It will be extended in y direction. So generally we can say if we have y equals a f of x and a is greater than 1, the graph will be extended in y direction, and if a is between 0 and 1, it will be contracted in y direction. It is easy to see this in sinusoidal functions. And sinusoidal functions, let me choose the pen tool, come down here. In the sinusoidal function, for example, if I draw a sine function like this, this is y sine of x, and if we have the 2 sine of x, the 2 sine of x will be like this, and the maximum is 2, minimum is -2, but in the first case max and min was 1 and -1. So here we see more easily that the graph is extended in y direction, but in the case of a parabola we can say the graph will be more sharp. Okay, and then let me say one final example in here. For example, if we have 2 times x minus 1 squared plus 2, we can say the vertex goes 1 unit to the right because of this, and 2 units up. Because of this, and the graph will not be like a y equals x squared, it will be like 2x squared, and it will be more sharp. It opens upward, it will be more sharp. It will be sharper than y equals x squared because of this 2. Okay, now we can go back to the question we had and solve it. For the quadratic function, okay, find the coordinate of the vertex. Now we know that this parabolic, this parabola or quadratic function is translated 3 units to the left and 4 units up. So the vertex is -3 and 4. Does the graph open upward or downward? We can say it opens upward because of this coefficient, which is positive. Find the equation of axis of symmetry. Axis of symmetry is the same as the x component of the vertex. The axis of symmetry is a line that if we lie the graph, if we fold the graph, it will lie on itself. So in the parabolic, in the quadratic functions, this vertical line is the axis of symmetry. Find the domain and range of the function. The domain of the function is all real numbers because there is no limitation here, and every number we can imagine we can substitute instead of x. So we can say the domain is all real numbers. We can also show it by an R with a line in here, which denotes that it's not an ordinary set, it's the real number set. And the range is because we know that the graph is like something like this, that it has moved 3 units to the left and 4 units up, and here the graph is drawn upward, where it is open, it opens upward. So we know that the y values is greater than or equal to 4. So if we want to write it in the interval form, we can write it like this, 4 and positive infinity, or if the student hasn't learned the interval, we can write all the real values which are greater than or equal to 4. Okay, that's it.